Okay, this is section 10.3, part 1. We're dealing with a different conic section. These are called hyperbolas. These things sort of look like two parabolas, back to back, but they're really not. Because you have slant asymptotes coming through these things. These are hyperbolas. Each one of these is called a branch. To form a hyperbola, you have to have two cones back to back, or point to point. Okay, hyperbola is now an example of a hyperbola. Will be if you have a plane that's breaking the sound barrier, he creates a shock wave, which is actually more conical shaped than this. But when you take it along the ground, when you're looking down at him like this, the shape of the shock wave looks like this. It looks like a hyperbola with the plane flying in this direction. And you can see these are especially, I guess, noticeable from carrier aircraft, or if they're flying over water, you can actually see this shock wave, So these are hyperbolas. They look like two parabolas, but they're really not. Okay. Let's take a look at what we've got with hyperbolas. Like everything else, we're going to start out with some basic vocabulary. We're going to have two vertices. And this is the center. These are our slant asymptotes. So each one of these is a branch. And inside we've got two foci. Okay, now what I'm going to do is come in and I'm going to blow up this part of it right here. Here's a vertex. And here's a vertex. And our two foci are out here. Our slant asymptotes actually come through, well, they should, I didn't draw this real well. Slant asymptotes are basically the diagonals of this rectangle with the center. And it goes through the rectangle like this. Okay, and here are our asymptotes. And they're slant, if you remember from last semester. This distance from the center to the vertex is A, and this distance is B. And A is always the distance from the center to the vertex. And unlike in ellipses, where A was bigger than B, this is not always true for hyperbolas. They can be different. The equation of this asymptote right here. Now, if you remember, we've got 2 points here. My y-intercept is 0, all right? My slope is going to be rise, which is B, over my run, which is A. So it's going to be y equals B over A times x. This one will be the same thing, except it is minus B over A times x. Rise over run. Okay. Now the equation for a horizontal hyperbola. In other words, this opens horizontally. Is we're going to have x squared over a squared. So far, this looks very similar. This is where we're different. It's a minus. Y squared over b squared. And it will equal to 1. So really, the main difference when you look at the equations is this minus sign. This opens up horizontally, our vertices, plus or minus a, 0. Foci, plus or minus c, 0. And again, because this is a negative, unlike in the ellipse where c squared is a squared minus b squared, in hyperbola, c squared equals a squared plus b squared. And your asymptotes, the equations of them, by equals plus or minus b over a x. Okay. For vertical, it's going to be sort of similar to this, except that now we're going to have y squared over a squared. So in other words, for horizontal, the first term is x. For vertical, the first term is y. And you notice that the a squared is always underneath it. Then it will be minus. Okay, our vertices here are not going to be 0, are going to be 0 plus or minus a, because now they're along the y-axis. Foci are going to be 0 plus or minus c. And now because my a goes up and down, asymptotes are going to be y equals plus or minus a over b x. And I'm actually going to draw a vertical one for you here so you can see what it looks like. And it looks very similar. Remember, this is going to be this little rectangle here that my asymptotes go through. Now there is a. There is a, because I've got a vertex here and a vertex here. Now this thing is going to look like this. And my foci will lie somewhere on the inside of it here. Okay. The steps to sketching asymptotes. First off is draw the central box. Here you use A and B. A is where your vertices are going to lie. And A obviously goes along the axis that it lies underneath. So if it's underneath the x squared, it's x. If it's underneath the y squared, it's under y. Step 2, then sketch your asymptotes. As the diagonals through box. Step 3 is to plot your vertices. These will either be a plus or minus a0 or 0 plus or minus a. Again, depending upon if it's below x squared, it's this one. This is if below y squared. And then finally, draw the branches. Okay, so I'm going to work a couple of examples here. I'll start out with a horizontal one. You're given an equation, x squared over 4. And you're asked to sketch, find the vertices, foci, and asymptotes. So the first thing I notice is that x squared is on top. So that means this thing is going to be horizontal. Okay. A is 2, square root of this number. B is 4. I'm going to go out 2 in the x direction, 4 in the y direction. Here's what my box is going to look like. My asymptotes then will come through as diagonals. Yeah, I know, this is terrible. Okay, because this is horizontal, it's under x. Here are my vertices, and so this thing is going to look like this. Okay, we need to find the foci. Remember, c squared equals a squared plus b squared. There's a squared and there's b squared, so c squared is going to equal square root of, or c itself will be equal to the square root of 4 plus 16, square root of 20, which is going to be 2 square roots of 5. So there's your c. The other thing we need to find then is our asymptotes. If you remember, this is A, this is B. Asymptotes are rise over run, so y will be equal to plus or minus B over AX, and now we plug our numbers in. It's going to be plus or minus 4 over 2x, which is going to be plus or minus 2x. And there is the information you need to work this. The next example, the equation is going to look a little funny. Okay, now I can tell this is hyperbola because of this minus. I can also tell that it's going to be vertical because that's my positive. But to get this equal to 1, I need to divide by 225. Alright, equal to 1. So 25 divided by 225 simplifies to y squared over 9. And this will simplify to x squared over 25. This is more of the form we're used to seeing. A is 3, B is 5, C is going to be equal to the square root of 9 plus 25, which is the square root of 34. Okay, so now we're going to graph this guy. I'm going to go 3 units. Draw my central box in the x direction, in the y direction, and then 5 units in the x direction each way. There are more or less of my asymptotes. This should go through the origin. There are my vertices. This thing is going to look like this. Whoop. Go through this point right here. And my foci then will lie out here similarly. Asymptotes. This is a little bit different. There's A. There is B, since it's vertical. So it's going to be plus or minus A over B x. So y is going to equal to plus or minus 3/5 x. And there's the equation of both asymptotes. And that's all you need to know for this one.